All right, I guess we're ready to start. Please welcome Abraham. He's our record breaker. He's here for the 4th time, so he's been here for every single mobile error happened yet. And today he's going to talk about Flutter and how to Flutter all the things.
So, does this mean if I don't come back next year, there'll be no more mobile era?
Probably.
All right, hello. What a great audience. Okay, cool. So let's talk about Flutter. Before we talk about Flutter, let's talk about me, because everything is about me, since we already covered that mobile era basically exists because of me. So I am Abraham Williams. I'm from a state in the US called Wisconsin. I work at a company called Bendyworks. We do custom web development stuff. And follow me on Twitter, because people tell me I have a great Twitter handle, so you should follow it. These slides are on slides.today, so you don't have to worry about taking photos. You can just check it out on the website and get all the references and links and everything that I link to. So, where I work, Bendyworks, we have a motto, shared joy and success in our craft, and that kind of guides us as a company and how we approach software development. And the reason I bring this up is I feel like it actually applies really well to Flutter development. As a Flutter developer, it provides the tools to build expressive, beautiful UIs and to let you share joy with your users. There's a lot of powerful theming APIs that can really make your application look special, and it can really bring a lot of joy to your users. One of the perks of using a Flutter app is that it has native-like performance. There's been a lot of evidence over the years that laggy applications, slow applications, actually frustrate users and drive them away from your application and make them spend less money. So by having a native-like performance, users can share their joy by giving you more money. And then as a developer, Flutter has something called Stateful hot reload, which is amazing. It's just great. Basically, Stateful hot reload is like you can enter some text in a form field, change some of your code, your styling, how everything looks. It will reload all of your changes, and the text will stay in that text field. Like the state as it is will just stay there. It's really a really beautiful and joyful development experience. So generally, when you think about Flutter, we think of it as for building cross-platform mobile apps. Traditionally, you've used Flutter so that you could build iOS and Android apps with a single code base. I was a little late on that slide transition. One code base. But what we found is that people are actually running Flutter in a bunch of different places. This is Flutter running on a Raspberry Pi. I don't know if you'd want to do that, but you could. It'll also run places like desktop OSs. So Flutter has support, or is working on support for Windows, Mac OS, and Linux. And actually, Dart, the latest version of Dart, just launched support for building self-contained executables with Dart. So you have a Dart file, you run a command, and it will generate a single file that will just run on your OS without any other dependencies. And then the thing that I'm mostly going to highlight today is Flutter for Web. It was previously codenamed Hummingbird, and I just had to leave it in because I really like this logo. So now, really when you think about it, it's cross-platform apps because it'll run on mobile, it'll run on desktop, it'll run on very low-end computers, and it'll run on the web as well. Something I do want to highlight real quick, web support is in a technical preview. There are things that don't work yet. There are areas that are rough. Google does not recommend that you use it in production yet. So since it's a technical preview, you want to have to either be on the Flutter dev channel or the master channel, and you have to enable Flutter for web. You have to enable web. So look something like that. When you're talking about supporting web and mobile, native mobile, or installable mobile, generally these are some of the frameworks that people look towards. So I want to give a little breakdown of some of the different approaches that these different frameworks take, because it's actually pretty interesting, the many different ways of accomplishing the same thing, but some of the trade-offs that you have in those. So Ionic, we'll start with Ionic. Fun fact, Ionic's office is actually directly around the square from where I work. They're good folk. So with Ionic, you're writing a website. Historically, you've been writing an Angular app. They've more recently added Vue support and React support, and you think you can probably run just about anything in Ionic nowadays. Once you ship it to a user's device, it runs in a web view, so you're essentially running a web server on a mobile device. And that gets served in Cordova or Capacitor, and that is the layer that allows it to access the native APIs on the device. So essentially, like, you're basically building a website and then shipping that website and running it from the device. The next kind of level is React Native. This is only React, so you're not going to ship an Angular app this way. One of the differences is that it uses, like, if you're shipping it to Android and iOS, it'll use the Android buttons and iOS buttons on those specific platforms. The nice thing about that is when iOS ships a new update and, changes the button radius by a pixel, your UI will look correct because it's using the native buttons. If you're using Ionic, they have their own themes that look very similar, but you have to wait for them to update it. And then React Native has this JavaScript bridge between your JavaScript code and the native code. And I've heard from some people that depending on your use cases, this could be some amount of a performance bottleneck. It's 3 a.m. for me, so I gotta hit a little coffee today. Hang on, I forgot to do something. So usually, I have a co-presenter with me, Pearl, and she couldn't be here today, so I brought a peacock in her stead. So this is Pearl the peacock for today, and since she's not here, if there are any factual issues with the presentation, it's probably her fault since she's not here to defend herself. Okay, so native script. You're writing web technologies. This has traditionally been more Angular focused, similarly to Ionic, but you can also write a bunch of other web stuff in it. I kind of think of native script essentially being the Angular native to React native, but it's more generic than that in reality. It also uses the OEM widget, so buttons on iOS looks the way it should. One of the things that they do a little different here that is really interesting is they use introspection on the iOS and Android apps to figure out the native APIs and then gives you JavaScript handlers in your VM so you can leverage those APIs. One of the neat perks of this is if you have an Android update that introduces a new biometrics API, which I think Android 10 did, you don't have to wait for native script to update and add support for that. You can just run your introspection API and get access to those new APIs. Okay, and then Flutter, the kind of bread and butter that we're going to talk about today, is probably the most different. First, you write Dart. If you haven't seen Dart, don't worry. I'll have a couple of examples later on. The Flutter team built all their own widgets. So one of the Perks of this is that you have like ultimate control over what gets rendered and how it looks. The downside is Apple updates their button look a little bit. You have to wait for the Flutter team to update their SDK. And then the other big departure is that it compiles to native code. On web, it's JavaScript. On I think everything else, it compiles to ARM code. So this is part of where it gets that performance because for like most of the other frameworks, you don't have to ship JavaScript and then on the low-powered device, parse it, execute it, and all that stuff. You're kind of doing that more on your development machine, and then shipping the more efficient machine code. Assuming that that sold you, you might want to create an app using the Flutter SDK. You do something like this. I have a sample app called Era of Dogs that you'll see highlighted a few times. That name can really be whatever you want. And not to like, if you're a cat person, I love you, it's fine. I'm actually more of a cat person myself, but I started out with I followed another example that used dogs, and I'm a fan of dogs, so I stuck with it. It'll generate something like this. So the lib directory is where you will put all of your shared code. That's where the most of your development will happen. You'll also notice that there's a web directory, an Android directory, and an iOS directory. These are platform specific, so if you need something just for iOS, then it would go there. And you also note there's this pub spec YAML file. This is where you pull in Dart dependencies. They have the package manager at the website pub.dev. So one of the current limitations of being in a technical preview is that it only supports web plugins if you are targeting web. What that means is that if you're looking at packages, it needs to say web in order for it to be supported on the web. Mostly this is because the security model around web is very different from around mobile. There's a lot of restrictions, especially around network requests that web cannot do, but a mobile app can do just fine. So most of those packages are all going to be written in Dart. Dart is what the majority of your application will be written in. So let's look at a little example of what Dart looks like. Dart is kind of interesting. I think of it as kind of, in the middle ground of like, it feels comfortable to everybody, but is a little different for everybody at the same time. So they were interested in making it feel familiar, whether you came from a dynamic language like JavaScript or a more strictly typed thing like Kotlin. Here's a good question. How many people are web developers? This side of the room. And this side of the room is all mobile developers? Yeah? Okay. So I was a little hesitant about this material because some of it is targeting people from web background and some of it's targeting people from mobile background, and I think I might have actually hit that fine line pretty well. So if you're coming from web, Dart works very similar. Originally, Dart was targeting JavaScript as its primary platform, so it works on event loop, very similar to how JavaScript does. You queue up some work, it'll do it, and then it'll keep looping through and finding the next item to process. So your development experience is really nice. It has just-in-time compilation, so as you're developing as you're working on a new feature, it's a real quick development cycle. But then it also supports ahead-of-time compilation. This is where it will output to JavaScript or ARM code, or depending on the platform you're targeting. It's also type safe, which is nice, although it is not non-nullable. But they're working on that, so hopefully in the future it'll be not non-nullable. Okay, so I come more from a web background, so the language that I usually compare Dart to, and I hear a lot of other people comparing it to, is TypeScript. So let's look at a real quick TypeScript example of some code, and then what that would look like in Dart. So this is defining a simple pizza class. We'll apply a property on it. We'll define a property on it called slices. We're explicitly saying number. TypeScript is actually smart enough that you don't have to say number. It knows it, but it's here just to show you how types work in TypeScript. And then you can define a constructor. In this case, it's also defining that there's a public property toppings that is an array of strings. And now we're going to do an asynchronous function called bake. And then essentially this is going to say, hey, after 5 seconds, we'll say that it's done baking. Don't actually eat pizza that's only been baked for 5 seconds. It'll be half baked, kind of like this example. And then in JavaScript, your code doesn't actually execute unless you define a function and run it. We arbitrarily named it main. It could be whatever you want in TypeScript. Inside of that, we're going to instantiate a new instance of pizza. And because we like controversy, we'll put some pineapple on that pizza. That's a good question. Is pineapple a common pizza topping in Norway? I'm seeing some nods and a couple of shakes too. We can argue about Vim versus Emacs later too if you want. And then because the main function is asynchronous, we can await for the baking to finish. And after it's done, we'll just log a little bit of a result saying, hey, it's done. We use a little string interpolation to say what toppings were on the pizza. And so that's a fairly simple, just plain TypeScript example of defining a class and using it in a function. Now, if you look at the equivalency in Dart, it actually starts out exactly the same. We have a class pizza. The types are a little different. You'll notice that the type definitions are switched from the property names. And we also have to explicitly list toppings as a property on the class. The constructor is a little bit more succinct. One of the features that Dart has that I won't really talk about too much is you can have named constructors. So you can have 6 different constructors for your class. Some of them can do different things. And then an asynchronous function. The async is in a different place. But inside of it, we see now probably the biggest difference from the TypeScript version. Instead of promises, asynchronous work is a future. And then future, so this future.delayed, delayed is actually a named constructor for the future class. And then we have duration, which is a custom type. And it has a seconds API. It also has like days API. Although I think if you're running a mobile app, saying run this in 1 day from now is probably not super useful. And then in Dart, if you want your code to execute automatically, you will trigger it from a main function, and Dart will just know to run that. The instantiation is very similar. One thing you'll note, or you should note, is there's no new keyword. Later versions of Dart got rid of new or made new optional because Flutter basically. Flutter instantiates so many instances of widgets that they just got rid of the new keyword altogether. And then we await. And finally, we have a print instead of a console log. So all in all, it feels pretty familiar. I think whether you're coming from more dynamic JavaScript or a more strict language, it should feel fairly similar or familiar, but be a little bit different. So we got a little Dart under our belts. Let's look at how we can use that in Flutter. One of the things you'll hear in Flutter is that everything's a widget. it's such a kind of mantra of the Flutter community that it's almost a joke now, except it's still kind of true. And what do I mean by a widget? So actually, if you have familiarity with like Swift UI or Jetpack Compose, this should actually feel pretty familiar as well. Essentially, you're instantiating a bunch of instances of classes, and then using those APIs. In Flutter, the very common idiom is that you will have child or children, and then you will build a tree of your components that way, or widgets, since it's Flutter. The Flutter team has provided a large library of widgets that are just ready to go out of the box. Some of them are very kind of all-encompassing and more complex, that do large app-level orchestration of layout. So this scaffold widget, for example, will control having like an app bar at the top and fly-out menus and a floating action menu. But there's also things that you might not necessarily think of as being widgets that control like margin around something, or media query is interesting. So if you're coming from designing for a mobile app, a mobile phone, that's a small screen size. If you're then thinking about supporting the web, you then have to scale up to potentially 4,000 plus wide pixels. So media query is a way that you can support multiple screen resolutions. In the sample app, it was a strip of cards, and it was all off on one little side, and it was small. So I defined a very simple example widget called center of page, and essentially it's like, hey, let's get the current size we're rendering at. If that's over a certain size, then we'll just put a bunch of margin on either side so that it's centered. And then anytime I'm rendering a list of things or a page, I can wrap it in that widget. And what you end up is that all the adorable dogs are all in the center. One of the things that I think is going to be interesting to see how the Flutter community approaches web from a user experience approach. It's like, I think about like a lot of mobile apps, when they added tablet views, essentially had a list of items, and then you would click on an item or tap on an item, and it would open the details on a mobile screen. Switching to a tablet screen, what a lot of them did is they just keep the list of items to the left, and then would show the detail pane on the right with the details of that. So I think we might see a bunch of web apps doing a similar pattern. I don't know if it's the best user experience for web, but kind of the UX of mobile apps versus web apps is a little different, so it'll be interesting to see how the community evolves. Okay, and then there's also some more kind of, there's widgets that do other things that, for example, create animations. We'll have an example of a hero animation later, which is very simple to implement, but you can do some, I want to control the opacity of this element, and there's a widget for it. You could argue, or I might argue, that there's almost too many widgets. Sometimes I spend like half a day just looking for the right widget, but that's probably a good problem to have. So if you're going to build your own custom widgets, which you probably will need to, you generally will do that with one of two different ways. One of the main ways is a stateless widget. This is generally fairly simple, but it will not maintain any state within itself. This is just a simple example that renders a little bit of text to the screen. If you were to compare this to, say, just plain old HTML and JavaScript using a web component, it might look something like this. if you were to compare that to, say, React, it could look something like this, unless you're doing React hooks, and then that's a very different example. But then it breaks the component model that I'm demonstrating. So I'm just pretending that hooks don't exist. But you probably need to maintain state. Most apps do need to maintain state. You probably have a user you have to log in. You have to remember who they are. You have to remember what page they're on. You have to remember what they've entered into a form. So generally, a lot of times you're going to be building a stateful widget instead. This gets a little bit different. It actually consists of two different parts. One is the widget part that's very similar to the state list widget that we were just looking at, but a lot of times it doesn't do much other than instantiate a sibling state instance. And this state instance is where you tend to do a lot of stuff. You'll actually define some state. In this case, we're going to just have a simple counter. And that's the state you're maintaining. Anytime you want to change that state and you want to tell Flutter to re-render your widget, you can update that state inside of a set state, or that parameter inside of a set state. It looks something like this. And this will have a build function, just like a stateless widget of what Flutter should actually render for that component. So since it's splitting out state and the widget in a stateful widget, it allows it to have long-lived state, and because the widgets get reborn every time it renders, every frame, it'll tear down all the widgets and rebuild them. And the state lives off on the side. That makes it so that Flutter can do that very quickly. And this is also what powers stateful hot reload, because the actual structure of what's being rendered, all of the widgets, can get torn down and rebuilt as needed, and what is currently set in state keeps living off to the side. Now I have an asterisk here, and that's because currently Flutter for Web doesn't support stateful hot reload, it just supports hot reload. Hopefully that's something that they will be fixing soon. So, you built some widgets. You want to look at them probably. It's usually if you're building an app, you need to look at something. So you'll generally do something like that in Flutter with the Flutter run command, or it'll look something like this if it's from the command line. This will launch it in a Chrome app. I personally use VS Code, so it has a start debugging command, and Android Studio. I gave up on that after 3 weeks because it was too complex, but I liked VS Code more. But it'll have an equivalent command. And I totally spaced on what my transition between those slides was supposed to be. Animations are fun. So one of the things that I think it was because of how widgets are reborn quickly, this enables Flutter to do quick rendering, which enables animations. I think it was supposed to be something like that. So there's a bunch of different types of animations you can do. One of the kind of basic ones, I'll have an example here. So this will be slowed down. So I don't actually know. It's probably like a quarter the speed or something. And it's going to be a hero animation. So what it'll be is that this is a detail view. It'll take this main image up here, move it to its position in the list on the other page. Or maybe not. It's supposed to be a YouTube video. All right. So if you go to the demo app, you can see a a couple of things on that example. So essentially, some things to keep an eye out for is, so from your perspective, the image renders in the center on the details page, and then when you go back to the list page, it'll swoop over and down and land in the spot of where it should be in the list view. And you'll note that there's not an image there to begin with. So it's a nice little swoop. If you try to do something like that on web, just with web technologies, it's almost impossible. So the fact that Flutter makes this very easy it's actually this easy. You include this hero widget on both pages you want, and as long as it has the same tag value, Flutter will automatically do the transition between them very easily. If you want to do more complex stuff, you can do all kinds of fancy animation things. I actually tend to think of Flutter as being more like a game rendering engine, and how it kind of approaches how it renders stuff rather than like a web app or something like that. So I think it allows you to do some really powerful animations. At the same time, you do have to get management buy-in to actually build that, but that's your problem, not mine. So the way that this actually works, on the web, it uses Canvas to do the actual rendering. In native and desktop, it uses Skia, which is the same rendering engine that Google Chrome uses. I don't know a lot about it, but Google Chrome's popular, so I think it works pretty well. I don't know if that's that might be more correlation than causation. You've built some stuff, you should test it. So Flutter fairly typically has three different kind of levels of testing. The base level is unit testing. This is actually provided by the Dart team themselves. They have a test package. These are very fast. They should probably be the majority of your tests. It's designed more for functions, classes, to make sure that your code handles all of the correct permutations correctly. The next level up is widget. This is a little bit larger. This is provided by the Flutter team. It's a little bit more boilerplate, but using something like this, you can build a user registration page with a form on it, and you can make sure that when someone is on that, or you can make sure that when that user registration form is being filled out, that it cannot be submitted if it doesn't have a valid password or it's missing an email address or something like that. So it's a little bit more, it's a larger bit of UI, but not a full user feature. The highest level and the slowest is integration, or they're also sometimes called driver tests. These are actually kind of neat because they can run on actual hardware. So if you have an Android device and an iOS device, you can actually run your app on that actual hardware. So you have very good confidence that your application will run on that actual hardware. This has a lot of boilerplate, and it's slow, so you don't want to have too many of them. But this is something you might test. When a new user launches my app, there's a button to register. They can go to the registration page, enter the registration details, hit submit, and then it'd be hard to test that they actually got an email, but you could test that the correct registration API was called. One of the downsides of the experimental test preview of web is that driver tests are not yet supported. Hopefully they will be soon, because they're key for asserting the functionality of your app. If Pearl was here, she would say test more things. She's not, so I put this quote up. She didn't actually say this, I'm just pretending that she said it. I asked her if she had some quotes she wanted to put in the slide deck, and she's like, no, just make something up. So I put this in. I think she probably actually wrote this slide, so technically she did say this. You've built an app. You probably need some users. So if you want to ship it to the web, you'll use Flutter build, specifically Flutter build web. When this happens, Dart actually has pretty good support for JavaScript. Since it's statically typed, it automatically does tree shaking because it just gets rid of, it knows exactly what functions you're going to call, so it gets rid of everything else. And then Dart has been building for the web for maybe 10 years. I actually don't know what the time frame is, but a number of years. So it actually has good minification support as well. So the outputted JavaScript will be about as small as you can get for the process. And then it'll build something similar to this. So essentially, if you're using custom fonts, it'll output that. It'll also give you an index.html file and then a Dart file, or a JavaScript file of your main Dart file. They don't have any, as far as I can tell, Flutter doesn't support split bundles yet. I think to be a valid, for the web to be a valid build target, they will have to support that, but it's probably something that's further down the line. Essentially, when you build a Flutter web app, you're building a single page app. So it just has an index.html file. Since they're static files, you can throw them up pretty much anywhere you want. If you want to put it on S3, or my example uses Firebase, so it's a quick Firebase deploy with a config similar to this. This is essentially saying, okay, I've put some files in this folder, upload those to your CDN, and then all requests that come in, send them all to index.html. So that's the single page app part, where if somebody comes into /user/5, then it'll still render the same HTML to them. The example app that I have up is at eraofdogs.web.app. It looks kind of like this. As an example of some of the kind of shortcomings that Flutter currently has on the web, coming from touch devices, it doesn't have a very good understanding yet of like a mouse cursor, and that when you're hovering over a button, it should transition to the clicking hand. I don't actually know what the cursor's called, but your mouse cursor should change. It doesn't do that by default, so I found an example online and modified it a little bit, and it made something like this. This is essentially, I don't actually have an example of where I use it, but this is a widget that anytime I have a button or something like that, I just wrap it in this widget. And now it's a little hacky. Maybe don't look at it too closely, but it works, which is what I needed for a demo, right? So if you're interested in getting started, I know that's kind of like a big whirlwind of lots of stuff. Where I would suggest going to get started, first, flutter.dev/web. It'll tell you a lot of the stuff about what channel you have to be on, the current limitations, if you have an existing Flutter app, how to potentially upgrade it. The example app that I have, I haven't published the source code for this yet, but I will probably have time to do that this weekend. In last December, I wrote a blog post a day on how to build a Flutter app, and you can find that at bendyworks.com/blog. If you're interested in blogging, I don't recommend doing it every day for a month. That's a lot of work. I made Pearl proofread all of my blog posts, and she was glad when I was done. We'll put it that way. They have a bunch of code labs. So these are more kind of concrete examples of how do I add Firebase, or how do I theme this material button. So they're a little bit more specific, but they're if a topic you're interested in is covered, they're pretty good code labs. There's a Git repo called Awesome Flutter. It's lots of Flutter things that are, as you'd expect, awesome. So there's a lot of blog posts, talks, sample apps, particularly useful packages, stuff like that. All right, and as I said, these slides are at slides.today. They will also be there tomorrow, but there's no .tomorrow domain, so it's just today. But all of the links, all the resources are listed there as well. And that's Flutter all the things. Thanks for coming.